Recording. Hello there. So today we will look into fundamental concepts and models for cloud computing. Here we go. So organizations or humans, they can assume different types of roles depending on how they relate to or interact with a cloud and all its IT resources. So in the following slides, I will go over these roles, the main roles, and identify their main interactions. So let's start with the cloud provider. So the organization that provides cloud-based IT resources is basically the cloud provider. Um, when assuming the role of a cloud provider, an organization is responsible for making all those cloud services available to cloud consumers, which we will discuss in a moment. And well, while making those services available, cloud provider and cloud consumer, they agreed upon an SLA, right? A document that has all the rules and service guarantees provided by the provider. Okay, so the cloud provider has to ensure all the ongoing operation of the cloud infrastructure and its services, etc. Okay, and cloud providers, they normally own the IT resources that are made available to those cloud consumers. However, you can also have some cloud providers that resell IT resources leased from other cloud providers. Okay, that's possible as well. So now, cloud consumer and cloud service consumer, it's a little fuzzy and tricky. So a cloud consumer could be an organization or even a human, a person that has a formal contract with that cloud provider, obviously to use the IT resources made available by that cloud provider. And specifically, the cloud consumer uses a cloud service consumer to access a cloud service. Make sense? So again, the cloud consumer, which is an organization or individual, uses a cloud service consumer to access a cloud service. Okay? Cloud consumer uses a cloud service consumer to access a cloud service. We'll explain here in a second this image. So let me get a pen here. My slides. Okay. So you have this organization A. This is the cloud consumer. Okay. So a cloud consumer which is the organization A, interacts with a cloud service from a cloud provider, cloud that resides within cloud A, okay, using a cloud service consumer to access the service. All right, makes sense? Example of cloud service consumer, the AWS API, the CLI. Okay, it's a piece of software. It's an API that enables the cloud consumer to use a cloud service. All right. Now, the person or organization that legally owns a cloud service is the cloud service owner. Okay, and so the cloud service owner can be the cloud consumer that we saw before, or it could be the cloud provider. Okay, the cloud provider obviously that owns the cloud that is providing that cloud service. Okay, so note that you can have a a cloud consumer that owns a cloud service hosted by another cloud, a third-party cloud. But it does not necessarily need to be the user or the consumer of the cloud service. Does it make sense? There are many cloud consumer organizations that develop and deploy those cloud services in other clouds, in clouds owned by other parties, just for the purpose of making the cloud services available to the public. Now, the cloud resource administrator can be a person, can be an organization. So this admin is responsible for managing a cloud-based resource, including cloud services, and this administrator, it can be or belong to the cloud consumer or cloud provider of the cloud that the service is running from. I mean, the cloud within which the cloud service resides. Make sense? But it could also be or belong to, because I'm talking about, it could be a person, okay, or the organization. So it could be a third-party organization contracted to manage the cloud-based IT resource. That's possible as well. So in here we have an illustration showing a cloud admin, cloud resource admin that belongs to the cloud consumer or is the cloud consumer. It is also the cloud service owner in this example. It owns cloud service A that resides within a third-party cloud, which cloud X, right? So now in this illustration here, we have an admin, cloud resource admin that belongs to the cloud provider or is the cloud provider. Okay, the cloud provider is the service owner as well of cloud service A, and it runs within cloud X. All right, just to illustrate the two possibilities: admins from cloud consumer or from cloud provider. And we have some additional roles. They are I just want to show you the main roles. Okay, there are others, but those are the what you will see in the literature, in contracts and etc. All right, so we also have a cloud auditor. It's a third party, often accredited, that conducts independent assessments of cloud environments, and the typical responsibilities associated with the auditor can include, for example, security evaluation of security controls, privacy impacts, performance, etc. And the purpose of having this independent cloud auditor is basically to provide an assessment of the cloud environment, an unbiased assessment, possibly endorsement as well, to for example, to help straighten the trust relationship between cloud consumers and cloud providers. Okay. We also have a cloud broker responsible for managing and negotiating the usage of cloud services between cloud consumers and cloud providers. Basically that. It also provides mediation services, right? Like service intermediation, aggregation, arbitrage, and all that. And we have, at the end, we have cloud carrier. It is basically the party responsible for providing the wire level, the physical connectivity between cloud consumers and cloud providers. Okay. And well, this is basically the network provider, the telecom provider, right? So now let's talk about organizational boundary, very important topic, especially for clouds. So an organizational boundary basically represents the physical perimeter that surrounds a set of IT resources owned and governed by an organization. Okay. Now, this organizational boundary, it does not represent the boundary of an actual organization, but the actual set of IT assets and resources, IT resources. Okay, and similarly, you have clouds. They also have organizational boundaries. So when we have an organization that decides to use a cloud-based IT resource, well, it's the cloud consumer, okay? It needs to extend its trust boundary beyond the physical boundary of the actual organization in such a way to include the boundary of parts of the cloud it's using the resources from. And this is very important for clouds. You'll see why in a moment. So a trust boundary is a logical perimeter that typically spans beyond physical boundaries to represent the extent to which IT resources are trusted. Okay, so as you can see there in the picture, let me get my pen here again. So you have an organization using a cloud service from cloud A. So this is the boundary, the organizational or boundary of that company. You have the organizational boundary of the cloud. The trust boundary for that company now includes parts of the cloud. Okay. Okay, so we reached the end of this little section here. Just as a summary, we've looked into the common roles associated with cloud-based interaction and relationships, and they include the cloud provider, cloud consumer, the cloud service consumer, right? Cloud service owner, cloud resource admin, etc. And we looked into organizational boundary, which represents the physical scope of IT resources owned and governed by an organization. And also we looked into the trust boundary, which is the logical perimeter, right? That, how can I say, it encompasses the IT resources trusted by an organization. Now I have a quick question for you guys. So this is quiz 2. You can just you can pause the video, go to Canvas, or you can answer this later. It's up to you. But what are some of the issues you would expect to arise when an organization's trust boundary is expanded to include a cloud service provider? What we've discussed about trust boundary, okay? An organization has its own boundary where it has its own IT resources, but it uses a cloud. It has to expand the boundary to include the cloud. What are some issues that may arise from that expansion? Just let me know, okay? There will be more questions. Okay, so an IT environment requires a specific set of features to enable the remote provisioning of IT resources that are scalable, measured as well in an effective manner. Let's take a look at those features or characteristics. So these characteristics or features, they need to exist to a certain extent for the IT environment to be considered an effective cloud, let's say. So the following six specific characteristics are common to almost all the cloud providers. So we have on-demand usage, ubiquitous access, multi-tenancy and resource pooling, elasticity, measured usage, and resiliency. We will discuss each of them in the next slides. And you know, how can I say, cloud providers will, and cloud consumers as well, they can assess these characteristics we discussed individually and or collectively to basically measure the value offering of a certain platform. Okay, so let's take a look at them. So our first feature or characteristic, it's on-demand usage. You know, a cloud consumer can access cloud resources, right? And it gives the cloud consumer the freedom to self-provision these IT resources. And once configured, the usage of these self-provisioned IT resources can be automated, right? Requiring no further human involvement in interaction, either by the cloud consumer side or the cloud provider side. Okay, and basically this results in an on-demand usage environment. Okay, you will see that in the literature as on-demand usage environment, on-demand, or how do you call on-demand self-service usage, etc. Okay, and basically this characteristic, this feature is present in almost all the cloud providers. Now our second feature, ubiquitous access, like the internet, right? So ubiquitous access basically represents the ability for a cloud service to be widely accessible. Okay, and well, to establish ubiquitous access for cloud services can require support for a range of devices, transport protocols, interfaces, security technologies, and so on. And in order to enable this level of access, generally requires that the cloud service architecture be tailored to the particular needs of different cloud service consumers or clients. So now our third feature, multi-tenancy and resource pooling. This is multi-tenancy basically is the characteristic of a software program to enable an instance of the same program, obviously, to serve different tenants, different consumers, and each is isolated from the other. Okay, we will discuss this later. But a cloud provider pools its IT resources in order to serve multiple consumers, or I have to be very careful here, to serve multiple cloud service consumers. Okay, and they use multi-tenancy models that usually rely on virtualization. Okay, and when they use multi-tenancy, basically IT resources can be dynamically assigned and reassigned according to the demand, according to cloud service consumer demands. I have to be specific here because they are different. Okay, if we talk about cloud consumer, as you saw before, it's different than cloud service consumer, right? And so resource pooling basically allows a cloud provider, like you see here, to pool large-scale IT resources to serve those multiple cloud consumers. In this example, we have two here just as an illustration. So cloud consumer A and B, right? And then different physical resources. Sometimes it can be virtual as well. Okay, they are dynamically assigned and reassigned according to the cloud consumer demand. Okay. Okay, our fourth feature, elasticity, very important for cloud computing. So what is it? It is basically the automated ability of a cloud to scale its IT resources, and usually in response to, it could be runtime conditions, it could be predetermined by the cloud consumer or even by the cloud provider. And elasticity is often considered a core justification for the adoption of cloud computing. Primarily due to the fact that it's closely associated with reduced investment. Yeah. So just to give you one example of elasticity, AWS. It provides you with what they call on-demand capacity reservations, where you can basically reserve capacity for your virtual machines in EC2, Elastic Compute Cloud. And with that, you can ensure that you always have access to EC2 capacity when you need it. Okay. And there you can specify the number of instances for that you want capacity reservations for, the instance attributes, instance type. There are different types you will see when we work with AWS, tenancy, OS, etc. Now our fifth feature, measured usage. Well, basically, it is the ability of a cloud platform to keep track of the usage of all its IT resources consumed by cloud consumers, right? And based on what is measured, the cloud provider can charge the cloud consumer for the IT resources that are actually being used and for the time that they have been used, basically. Okay. And in this context, if you look at it, it is measured usage is closely related to the on-demand feature. Now our last feature, resiliency. What is resilient computing? It is basically a form of failover. What is failover? Failover will distribute redundant implementations of IT resources across different physical locations. And IT resources can then be pre-configured so that if one IT resource becomes deficient or unavailable, the processing can be automatically handed over to another redundant implementation of the same IT resource. So when we talk about cloud computing, what is resiliency in this context? Well, basically the same. So resiliency here refers to the redundant IT resources within the same cloud. Distributed across multiple clouds too, or even in different physical locations. Okay, so yeah, so and then cloud consumers can increase both the reliability and availability of their services, applications by leveraging this resiliency of cloud-based IT resources. So here, just to illustrate resiliency, in a resilient system, in which in the example here we have Cloud B hosting a redundant implementation of Cloud Service A. You see Cloud A hosts its own Cloud Service A, Cloud B hosts Cloud Service A as well. It's a redundant IT resource. Okay, and why do we have this configuration here? It's just to provide a failover in case Cloud Service A on Cloud A, let's say this one here becomes unavailable, right? The process will be able to hand it over the tasks from Cloud Service Consumer A here to continue using Cloud Service A. Okay. All right, now let's take a look at some cloud delivery models. Okay, so cloud delivery models, they are basically a combination of the IT resources offered by a cloud provider. And most of the delivery models, the main delivery models, they are infrastructure as a service, IaaS. We will discuss each one of them, okay? Platform as a service, PaaS, software as a service, SaaS. And there are many other specialized cloud delivery models, such as storage as a service, database as a service, security as a service even. There is communication as a service. I've seen integration as a service, testing as a service, process as a service. There is everything as a service. We will focus on some of them, like the infrastructure, platform, and software as a service. Okay, obviously we'll look into containers and also function as a service, right? I don't have in my slides here FaaS or serverless computing, which is it's something very useful, guys. You will see later. And just to give you some examples of actual services, function as a service provided by an actual cloud provider. You have AWS Lambda, you have Google Cloud Functions, and Azure calls them functions, Azure Functions, yeah. We will discuss them later, but it's interesting because, like I mentioned before, you pay for function executions, not idle time. So infrastructure as a service, IaaS, it represents a self-contained IT environment comprised of infrastructure-related resources that are accessible and manageable by cloud service-based interfaces and tools. All right. So in contrast to traditional hosting or outsourcing environment, with IaaS, those IT resources are typically virtualized and packed into bundles. Okay, so some typical we call raw IT resources, because we're talking about infrastructure. Okay, they can be hardware like servers, VMs, right? Servers, network resources, connectivity, OSs, etc. All right. So a core component of IaaS is our virtual server, okay, VMs we've discussed before. So virtual servers are deployed by specifying the IT resource they require, CPU, memory, storage, etc. All right, and these virtual servers, they are fully configurable by the cloud consumer while still remaining elastic. And by the way, when you are the cloud consumer, you are renting the virtual server from a cloud provider, you are responsible for its management, right? It's your server, okay, but it's running on the cloud, basically. Examples, the AWS EC2, Azure, I don't remember how they call, well, Azure VMs, okay. And here, just an illustration of a cloud consumer using a virtual server within an IaaS environment provided by this cloud provider. And cloud consumers, they are provided with a range of guarantees in contracts with the cloud provider, and related to, say, capacity, performance, availability, etc. So now PaaS, platform as a service, different than IaaS. In this model, we have ready-made environment built upon already deployed and configured IT resources. It provides a set of pre-packaged products and tools used to support the entire delivery life cycle of custom applications. Basically, the cloud consumer, when, let's say, when a company, an organization wants to use PaaS, basically when the consumer wants to extend its on-premise environment into the cloud, and for scalability or economic purposes, and the cloud consumer wants to use a ready-made environment to replace its entire on-premise environment, right? Sometimes the cloud consumer can also, well, the reason behind adopting PaaS could be the cloud consumer wants to become a cloud provider. It deploys its own services and provide this to external cloud consumers. Okay. So, like I mentioned, differently from IaaS, here with PaaS, you as the cloud consumer, you don't have the administrative burden or management burden of dealing with all those IT resources, which the organization can focus on the application deployment, development, etc. Some examples, Google's App Engine with Python and Java, for example, web hosting environments, and there are many others. So in the figure here, just as an example, you have a cloud consumer. It accesses a ready-made PaaS environment provided by that cloud provider. The question mark here, it represents that the cloud consumer is shielded from the implementation details of that platform. Okay, so it's already deployed, configured, etc. Now, software as a service, SaaS, basically refers to a software program positioned as a shared cloud service and made available as a product, or we could say a generic utility. Okay, So this SaaS delivery model is typically used to make reusable cloud services widely available and often commercially, right? To a range of cloud consumers. And guys, there is an entire marketplace around software as a service products. And they can be leased, can be used for different purposes. And as such, you don't, as a cloud consumer, you don't have much control, admin control over the service. Sometimes they are, you can configure them, but you don't have as much control over them. Which is one of the features, one of the characteristics of this software as a service, right? So software as a service software may be provisioned by a cloud provider, but not only the cloud provider will be the owner. Sometimes you as a cloud consumer, you can develop your product as a software as a service and run it on a cloud provider, on a public cloud provider, okay? Examples: Office 365, Google Apps for Business, etc. Now, just putting all the most common delivery models. So, IaaS infrastructure. So we saw Amazon EC2, but you have all the others. You have Google Compute Engine, and etc. So storage as a service, OneDrive, Dropbox, Google Drive, right? Platform as a service, well, Azure provides that, but you can also have Open PaaS suite, the App Engine. So they are pre-configured platforms ready for deployment, ready for application development, and etc. Database as a service, you can have Oracle Data Cloud, for example, Dynamo. Okay, function as a service. We talked about OpenFaaS. We will have some hands-on that as well. Cloud functions, Azure functions as well, and software as a service. So Office 367, Slack is a software as a service. Salesforce, the Google Suite. Okay, just some examples. And here we have a comparison of typical cloud delivery model control levels. We've been discussing about, what kind of management control you have over it. I gave you some examples, but here I have the summary of all what we've discussed. So with IaaS, we have full control, full access to your virtualized IT resources and physical resources as well. Now with platform as a service, that access, control level is limited. Only IT resources relevant to usage of platform. And for software as a service, it's usage only. Okay, you have only front-end access. And here we have, just to give you an idea of the activities carried out by cloud providers, cloud consumers in relation to the delivery models. So let's start with IaaS. So what can you do as a cloud consumer? Well, you configure, you set up, you manage your infrastructure, your servers, right? You want to install a web server on a server running on a cloud. You are responsible for the management for everything there. And on the cloud provider side, it provisions the service, monitors, and manages physical IT resources that will run your virtual IT resources. Now, for platform as a service, the consumer will, develop, deploys, and manage cloud services. All right. What is the cloud provider activity or responsibility? It's the pre-configuration of all the platforms, and it also provides the underlying infrastructure. And software as a service, as a consumer, you use and configure the cloud service. The cloud provider it is the one that implements, manages, and maintains that cloud service. Makes sense now, right? So just to provide you with another comparison and another example of the different delivery models and the users of each model. For example, for infrastructure as a service, infrastructure and network architects are the most common users, right? And the provider provides a server storage network and everything to support the infrastructure. Now, platform as a service, you have application developers as users. This model provides a configured OS and all the application, all the platform required for application developers, for example, all pre-configured. And software as a service, you have basically the end users as users. And what is provided? Well, all the infrastructure, all the OS and applications required for those the software that will run as a software as a service, and the actual packaged software. Okay. Okay, so we talked about cloud delivery models. Now let's take a look at cloud deployment models. So a cloud deployment model represents a specific type of cloud environment that is primarily distinguished by ownership, size, and access. These are the four main cloud deployment models. So we have public cloud, community cloud, private cloud, and hybrid cloud. Let's take a look at them. So our first deployment model, public clouds, as the name says, it's a publicly accessible cloud environment. It's owned by a third-party cloud provider, and the IT resources on those public clouds, they are usually provisioned via the cloud delivery models that we've discussed. The IaaS, PaaS, SaaS, etc. Okay, and those resources, those services, they are offered to cloud consumers at a cost, obviously. And the cloud provider is responsible for the creation, the ongoing maintenance of all the cloud environment and its services, monitoring, etc. All right, and here we have just an example of organizations. They act as cloud consumers, like we've seen before, and they access the cloud services or IT resources made available by those different cloud providers. So now just let's take a look at the benefits and drawbacks of public clouds. Obviously, availability, it may be higher than on-premise infrastructure, right? Scalability as well. There is an excess of resources in comparison to on-premise resources that you can scale automatically your resources on the cloud, on a public cloud. Accessibility, well, and it's ubiquitous access. And cost savings, reduced upfront expenditures and maintenance costs that we discussed before, compared to on-premise resources. Now the drawbacks, let's go. So integration limitations. Okay, business integration can prove difficult due to data stored off premise. We've discussed that a little bit about different regions that the data will be stored. The consumer doesn't know where it is stored, right? So there is that integration limitation there. And there is reduced flexibility and forced downtime, because your business will become subject to provider downtime. I'd say it is a drawback because you are subject to their schedule for their maintenance schedule, for their downtime schedule, and not your own. So you don't have much control on when it should be maintained or not, right? Now, private clouds. So usually a private cloud is owned by a single organization. Private clouds will then enable the organization to use cloud computing resources, cloud computing technology, in order to, for example, centralize access to IT resources by different parts of the company, different locations, departments, etc. Okay. Trust boundaries tend to be less of an issue because, again, it's owned by that single organization, usually in within the boundaries of the organization. So administration of a private cloud may be done internally or using an external contractor. It's like you have on-premise resources, but it's on a cloud that is that provides services to other parts of the company or departments. Does it make sense? So in the figure here, we have a cloud consumer in this organization's on-premise environment. Okay, it's a private cloud. It accesses a cloud service on that private cloud. Just a simple example. So now let's take a look at the benefits and drawbacks of private cloud. Well, just due to the fact that they are owned by a single enterprise and organization, you can think of a private cloud as an on-premise infrastructure or cloud. So let's take a look at the benefits. It's easier to support, right? It's local, it's in-house, easier to support and troubleshoot thanks to direct access. There is much more control, granular control over upgrade and downtime schedules, which is not the case with public clouds, right? You define, as the owner of this private cloud, you define when you want to have downtime for maintenance and upgrades. Monitoring can be expanded based on organization needs. But the drawbacks, now, there is a substantial upfront cost. I mean, it is an on-premise infrastructure, but it's a cloud that provides cloud services within the organization, right? And with that, you also have ongoing maintenance costs. You have to ensure the software you deploy is compatible with your client base, etc. You got the picture. You have to maintain as if it's like we discussed before, it's an on-premise environment, right? And then we have community clouds. A community cloud is very similar to a public cloud, except that its access is limited to that specific community of cloud consumers. All right. One example is healthcare clouds. Only healthcare providers will use the cloud. So the solutions, the services are tailored to that community. It's pretty interesting, right? Um, um, so the community, this community cloud could be jointly owned by the community members or even by a third-party cloud provider that will provision um, uh, uh, like it'll provision a public cloud with some access, right? Um, the member cloud consumers of that community, they typically share all the responsibility for defining, updating, evolving the community cloud. Now let's take a look at the benefits of community clouds. So because a community cloud is shared between all the community members, so the costs can be shared, and you have multi-tenancy that enables economy of scale, and support and maintenance can also be shared. All right, but the drawbacks are the ownership of cloud and underlying resources may not be clearly defined. Responsibilities for maintenance and support may be ambiguous. Security compliance may be different for each organization, leveraging shared cloud resources. So it's not very clear, and it's not very straightforward how community clouds are managed. You need to have a really good plan to responsibility and maintenance plan for this kind of clouds. And we have hybrid clouds. A hybrid cloud is basically a cloud environment comprised of two or more different cloud deployment models. For example, a cloud consumer may choose to deploy a cloud service that processes sensitive data into the private cloud, and then it'll use a public cloud to deploy services that will process less sensitive data. Makes sense, right? The creation and maintenance of hybrid clouds can be difficult and complex due to environment and management disparity. It's not an easy task to configure a hybrid cloud. But one example here, the organization is using both a private and a public cloud through a cloud service consumer using the cloud service. So public data is processed in the public cloud and sensitive data in the private cloud, for example. Now the benefits of hybrid clouds. There is increased flexibility in terms of resources. Well, basically you have your private cloud, your private cloud resources, and your public resources, right? And you can even have the same cloud service deployed in the private cloud and the public cloud. So if the private cloud service is unavailable or even exceeded the its load, then you can use the public cloud, can do something like that. It's great for transitioning to a public cloud. So organizations may start with a private cloud and see how it goes, and then slowly transition to a public cloud. Public clouds may be leveraged for fault tolerance, like I just discussed that, right? For fault tolerance and high availability reasons. Control over sensitive data and where it's stored, processed is higher, right? You have more control over that. Now the drawbacks Rules and procedures may be difficult to define and enforce, which one to use, and etc. Data retention, processing, and transit may be difficult to control in some situations. Security compliance may be difficult due to organizational trust boundaries, because then remember, you are expanding the trust boundary, and that maybe it's not easy. And that's it for today's video. I just have a resource here if you want to watch cloud deployment, a video on cloud deployment models. It's very short, just to give you an idea of what we've discussed about deployment models. Okay, so that's it for today, and see you next time.